I've taken the circuit off of the breadboard and put it onto one of these prototype PCBs. I've got a couple of reasons for this. One is that the circuit is pretty well hammered out. I don't think I'll have to make many changes to it from now on. So it's nice to have something a bit more sturdy and stable. And also the connections in the breadboard add a lot of parasitic capacitance, and the big long leads on the resistors and stuff add a lot of parasitic inductance. And that starts to matter at high frequencies. And since the largest component of the noise I saw was from radio, I figured something like this that gets rid of most of that parasitic inductance and capacitance would give me a much more honest look at how much radio I could expect to get in a final design. So to give you an idea of the layout, the output is going out this audio jack here, and then I made some terminals out of cut-off leads of the resistors. I have one for the positive supply, the negative supply, the ground, which this circuit is driving, and also another terminal for the output, which is the same as the audio jack there. I've got another terminal here for the output of the DC offset correction, and then these three terminals back here for the electrodes. I have my two signal electrodes on the outside, and the center terminals for the ground electrode. Before I turn on my circuits, I like to do some sanity checks to make sure I'm not going to blow them up. So I got my multimeter here in beep mode. Beep beep! And the first thing you do is make sure that I'm not shorting together the positive and negative supply. Alright, that's fine. Now I gotta make sure I don't short either of those supplies to ground. Alright, that looks fine. Then I gotta make sure that the supplies are going to the right pins on the different chips. So the negative supply should be here. Alright, the positive supply over here. That's fine. And on this chip, positive supply somewhere else. Yep, that's good. And then negative supplies over here. Alright, so at this point I can be reasonably certain that even if it doesn't work, it won't blow up. And now that I'm reasonably sure it won't blow up, I want to check to make sure that the DC offset tracker is working. So right now I have the multimeter clipped between the ground that the circuit's driving and the output of the circuit, so the multimeter should stick around 0 if this is working. So let's go ahead and clip this on the battery. Alright, so right now the output's railed, but there's nothing here on the input, so I don't think I could expect it to stay around 0 there. So there it goes, sticking around 0. I can give it a bit of a different DC offset by moving my fingers around. It looks like it's trying. And now, just to make doubly sure, I've got the multimeter clipped into the output of the DC offset tracker, so I can see what DC offset is being subtracted off. And so with no inputs to it, the output of the DC offset tracker is railed, which is why the output of the whole circuit was railed. It's too much DC offset for it to correct. But when I connect these guys together, I can see that the DC offset tracker does converge to some voltage. So I think I can say that this is working. And now for the real test. Here we go. That looks nice. So I've got a nice heartbeat. There's still some noise on it, which I can take a look at later. But for the most part, this looks pretty good. I'm going to push on these electrodes to see sort of what happens. I got a bit more noise from pushing down on one of the electrodes a bit harder. And actually, one more thing before I move on. I want to make sure that all this noise I'm seeing is actually coming from my circuit and not from the cable running to the computer. So I'll unplug the cable from my circuit, and I got no noise at all. So this noise here is definitely coming from my circuit and isn't being picked up by this cable. And now that I know that the noise is coming out of my circuit and not being picked up by the cable going to the computer, I want to find out if it's being generated in my circuit or if it's coming in through the electrodes. So here I have another recording. The other recordings were taken yesterday, and it looks like today, for some reason, I have more noise. Now I'm going to disconnect the electrodes from the input and just short all the inputs together and see if I still get all this noise. So here are all my inputs shorted together. So now that there are no electrodes on it, anything I have coming out of the output is either being generated in the circuit or being picked up in some other way. So let's start recording and see what we get coming out of this. So there's basically no noise now, or a lot less than there was before, which means that almost all the noise that I saw earlier was coming in through those electrodes. Here's a section that I've amplified to see what that noise is, and here's what it sounds like. It sounds like 60 hertz, and if you zoom in, you can see a nice clean sine wave there. And since 60 hertz noise is common mode, looks like my common mode rejection could be improved a bit more. So that's the next thing to work on. So that's it for this video. Not too much, just showing off the new build, getting it to work, and taking a look at what kind of noise I'm dealing with. And in the next video, I'll try to get rid of that noise.